Okay, deep in the heart of the Himalayas, there's this ribbon of steel that now stitches together two sides of a massive gorge. Today, we're diving into the story of the Chenab Bridge, and let me tell you, it's a true marvel of modern engineering that absolutely redefines what we think is possible.
I mean, just look at that. That's it right there. This is the world's highest single-arch railway bridge, just hanging there over the Chenab River. It's way more than just a bridge, it's a statement. It's really a testament to human ambition staring down one of the most formidable landscapes on the planet. Someone described this project as, get this, an astonishing feat that melds human ingenuity with the breathtaking beauty of this landscape. And you know what? That really gets to the heart of it. This whole story isn't just about building something functional. It's about raw ingenuity going head-to-head with some of the toughest geography on Earth.
So, to really get your head around the scale of this thing, let's throw some numbers at you. First up, height. The deck of the bridge, where the train actually runs, is a staggering 359 meters above the riverbed below. We're talking almost a third of a kilometer straight down. Just imagine that drop.
And if you're trying to picture that, here's a little perspective for you. At 359 meters, the Chenab Bridge is actually taller, yes taller, than the Eiffel Tower. Seriously, picture that iconic landmark in Paris and then imagine a train running right over the top of it. That's the mind-blowing scale we're talking about.
Okay, next up, let's talk length. The whole thing stretches 1,315 meters. That's more than a kilometer of steel and concrete bridging this absolutely enormous gorge.
And finally, the sheer weight of it all. The bridge is built from 27,000 tons of steel. Can you even imagine? That's just an immense amount of material. And remember, all of it had to be fabricated, then hauled out, and then assembled in this incredibly remote, difficult-to-reach location. All right, so looking at all this, you have to be asking yourself, why, right? I mean, why on earth would you build such a colossal structure in a place like this? What was the whole point behind this monumental undertaking? Well, it turns out this bridge is the absolute key, the critical link in a much bigger project. It's part of a new railway line designed to connect the Kashmir Valley with the rest of India. The goal here was huge, to create a reliable, all-weather way to get in and out, something that could boost the whole region's economy, move goods way faster, and just completely transform life and connectivity for millions of people.
But here's the thing. Before you can build that connection, you first have to conquer the very ground you're building on. And the geology of the Himalayas? Well, it's notoriously complex and unstable, and that was the first massive hurdle the engineers had to face.
So, to really get what they were up against, you have to look at the ground itself. All these fancy geotechnical ratings for the rock at the site, they basically all came back saying fair to fair poor. Now, in simple terms, that means the engineers were trying to build on rock that was fractured, blocky, and just plain unreliable. It's pretty much the worst kind of foundation you can imagine for a structure this massive.
So what do? How do you solve a problem like that? Well, you don't just build on the mountain. You anchor the bridge to the mountain with absolutely enormous foundations. The bases for that main arch are about 40 meters high and 50 meters wide. They are just these colossal blocks of concrete that literally lock the entire structure deep into the rock.
And it didn't stop with the foundations, not even close. The entire mountainside had to be reinforced. We're talking about spraying the slopes with a thick skin of reinforced concrete, they call it shotcrete, and then literally pinning the rock together with thousands of steel bolts, some of them up to 11 meters long. It's a staggering amount of engineering that you'll never even see.
Okay, so once the ground was finally secured, the bridge itself had to be designed to survive a whole gauntlet of external threats. This was never just about holding up a train. No, this was about withstanding the full, raw force of nature in the Himalayas. The engineers really boiled it down to three main dangers they had to account for. First, the ferocious winds that just tear through that gorge. Second, the immense seismic power of the region. We're talking major earthquakes. And third, potential security threats, like blast loads.
So to handle the wind problem, they actually built this incredibly detailed model and shipped it to a specialized wind tunnel all the way over in Denmark for testing. And the results? The design was proven to withstand wind speeds up to an insane 266 kilometers per hour. And just in case, there are sensors on the actual bridge that will stop all train traffic if the winds even get close to 90 kilometers per hour.
Now, what about earthquakes? Well, the bridge happens to be located in India's highest-risk seismic zone, so it had to be designed to withstand a massive magnitude 8 earthquake. That is just an incredible feat of resilient engineering.
And then there's security. The bridge is literally built to take a hit. It can withstand a blast equivalent to 40 kilograms of TNT. How? It's made with this special 63mm thick blast-proof steel. And get this, the piers are designed so that even if one gets heavily damaged, the bridge itself won't collapse. That's some serious planning.
All right, so the foundations are secure. The design is super robust. Now we get to the most dramatic part of the whole story, the construction. And specifically, the absolutely breathtaking challenge of closing that massive steel arch.
I mean, seriously, just think about that for a second. How do you actually build a 467-meter steel arch, piece by massive piece, while it's all just hanging hundreds of meters up in the air over a gorge? How is that even possible?
The answer is a pretty amazing technique called the cantilever method. Basically, what they did was build the bridge out from both sides at the same time. You had these huge cranes sitting on the bridge deck, and they would lower each massive steel segment of the arch into place one by one. After each piece was lowered, it was secured with temporary cables, and then they just repeat the process, with both halves inching closer and closer to meeting in the middle.
Yeah, this diagram really shows you how it all worked. You can see the arch segments being lowered into place, held up by those temporary stay cables that anchor everything back to the piers. It was this slow, super meticulous, and you can bet incredibly high-stakes balancing act, all happening hundreds of meters up in the air.
And all of that work, all of that tension, it all led to this moment. On August 13, 2022, the two halves of the arch finally met in the middle. The installation of this final piece, which they called the golden joint, officially completed the arch. It was the triumphant climax of the entire incredible construction project.
So, after all the technical marvels and all of the amazing engineering feats, it really comes back to the human impact. This bridge wasn't really built just to be a record breaker. It was built to connect communities, to spark development, or to put it simply, it was built to significantly change people's lives for the better.
The Chenab Bridge it's proof that with enough ingenuity and pure perseverance, we can overcome even the most daunting challenges imaginable. It really makes you wonder, doesn't it? What impossible challenge, what impossible landscape will engineering conquer next?